Good morning, students. Today we will start our fourth experiment, 823 priority encoder. So this is the logic diagram, block diagram of the 823 priority encoder. We have not mentioned logic diagram. So in 823 priority encoder, we will be having 8 inputs, namely D0 to D7, D0 being lowest priority and D7 being highest priority, and we will be having output Q0, Q1, Q2. We can include enable pin, but we are not going, in our experiment we are not going to use enable pin. Just we will be directly taking the priority into consideration and we will be activating the output. So the truth table here consists of 8 inputs and 3 outputs. We will be having 8 inputs and 3 outputs will be having. So now we will be going with the explanation part. Now we are having D0 to D7. D0 will be the lowest priority and D7 will be the highest priority. And the outputs are Q0, Q1, Q2. So obviously it represents 0 to 7, 0, 0, 0 to 1, 1, 1. Now let me take the explanation part. So first of all, we will take the highest priority into consideration. See, this one is the highest priority of the D7 bit. D7 bit highest priority. So when D7 bit is active, that means it is 1. It is 1. Then what happens means, it is immaterial whether D6, D5, D4, D3, D2, D1, D0, whether they are 0 or 1, it doesn't care. When D7 is active, it doesn't bother about what D6, what D5, D4, D3, D2, D1. It immediately generates output as Q0 1, 1, 1. That means 1, 1, 1. It is a 7th bit. 7th bit. It includes 7th bit. Now, if at all, the second case, if D7 is not active, it is inactive, 0, and D6 is 1, then whatever may be the cases between D5 to D0, it will present output 1, 1, 0, which is nothing but 6th bit, 1, 1, 0. So, in order to D6 to be active, D7 should be inactive, because D7 being the highest priority, if D7 is inactive only, then only D6 will be active, and the output will be the D6. D6 will be presented at the output. So obviously we will be getting 1, 1, 0. Then the case goes to D5. Here D7 and D6 being inactive and D5 is 1, regardless of whatever may be the input between D4 to D1, it will be presenting at the output 1, 0, 1, 1, 0, 1. That means 5th bit. Likewise, it goes with the 4th bit, it goes with the 3rd bit, it goes with the 2nd bit, it goes with 1st bit, and then it goes with 0 bit. So this is the case. See here, the lowest priority, D0 being the lowest priority, if it has to be active, this D1 to D7 should be 0. They should be 0. Then only D0 can be active. Otherwise, D0 will not become active. So, how we will be writing this in the coding format is mostly we will be writing in if else statement. Now we will be going with the if else statement. Now if you go with the case, now here see, you already know library IEEE is the first thing what we will be taking. Then library IEEE dot std underscore logic underscore 1164 all, and use IEEE dot numeric underscore as so these are the library parts that we will be writing. Now if you go with the entity, we have already discussed in so many classes, entity is nothing but a black box of the circuit. Inputs, it presents inputs and outputs. Now entity underscore name, which we have given priority encoder. is port. So we will be having 8 inputs and 3 outputs. So A, here we have taken unsigned. We can go with std underscore logic underscore vector. In the coding we will be going with this std underscore logic. Here also I will be going with std underscore logic underscore vector. So here A being 7 down to 0, output Y is 2 down to 0. 7 down to 0, I have already told you, 7 down to 0 means A7 is the highest priority, A6 next priority, A5, A4, A3, A2, A1, A0. So like this. So Y0 is Y2, Y1, Y0. Now we will be ending the priority underscore encoder. Then we will be starting the architecture. Architecture name we have taken as behave of entity underscore name is priority underscore and PRI underscore en is will begin the process. In the process the sensitivity list will be including the input bit. Now the process is beginning. Here the statement is like this: if the 7th bit, that means 8th bit, in braces 7, this is the 8th bit, is 1, then the output is written as 111. Else if, that means if this 7th bit is not 1, it goes with the 6th bit. If the 6th bit is 1, then it will be, at the output it will represent 110. If the 6th bit is also not 1, then it goes with the 5th bit. If the 5th bit is 1, the output represents 101. Likewise, it goes with 4th bit, 3rd bit, 2nd bit, 1st bit. Lastly, it goes with 0th bit. This is being the lowest priority. So 0 bit it writes 000 at the output. Else, if all are zeros, if you got all as zeros, no bit is active. From 7th bit to 0 bit, no bit is active. Then it writes XXX. Then it writes XXX. That means it doesn't know what actually it is active. So we will be ending the if statement, we will be ending the process statement, and we will be ending the behavior of the circuitry. Now the implementation part, we will go with the implementation part. As we already know, we are using xilinx software. Now you see, this is the code which we have written. There, whatever written, that is the code, is this one. So library IEEE, and I can remove this part. This is IEEE dot numeric underscore std underscore dot all. This I can remove. So this is not at all needed. So what I will be doing is this one I will comment it. This one I will comment it. Now here we are already written, see, A bit in std underscore logic 7 down to 0, Y out std underscore logic 2 down to 0. We are ending the entity, then we will start the behavior, start the architecture with the begin statement, then we go with the process statement, then we will be going with the process will be beginning. It checks for the 7th bit, then 6th bit, then 5th bit. Likewise, it goes to 0th bit. Based on the priority, the output will be given as from 111 to 000. Else, if at all, if any one is not active, the output will be given as XXX. That is, Y implies XXX. That is the. So we will be closing the if statement, process statement, and the architecture. Then we have to write the test bench for the circuit. So for the past 3 experiments, we have already discussed test bench. We will be creating the entity, then we will be creating the architecture. In the test bench, we have to write the component. Here we have to write the component. So component is nothing but whatever we have written in the entity, the same thing we will be writing. A being the in std underscore logic and y being the out std underscore logic. Then we have to go with the declaration part. So in the declaration, what we will be assigning signal A std underscore logic underscore value to 0. So here we are assigning this value to 0. Then the signal Y, I have already told you that inputs and outputs should be defined as signals in the test bench. Then we port map it. Then we will be writing the stimulus here. If A, the value is like this, the way is, if the A value is like this, 1110010, what will be the output? After 100 nanoseconds, if the value is like this, what will be the output? After 100 nanoseconds, if the value is like this, after. So, for this, see, here we should get the 7th bit. That means we should get output as 111 per first instance. Second instance, 7th bit is not active, but 6th bit is active. So, we should get 110. In third instance, we should get 101. Fourth instance, we should get 100. So this is how we have written the test bench in such a way that the stimulus what we have written in such a way, so that the output we have to get in that fashion. Now we will be simulating whether the output we are getting in that fashion or not. So we will get the simulation output now. So if you check it, see, for this instance we got 111. That means because 7th bit is active. Because 7th bit is active, it doesn't bother about the next inputs. Here 7th bit is inactive, but 6th bit is active. That is why 110. Here 7th bit, 6th bit is inactive, 5th bit is active. Here 7th bit, 6th bit and 5th bit are inactive and 4th bit is active. Likewise here also 3rd bit is active, 2nd bit and 1. So we have framed the stimulus in such a way to get 7, 6, 5, 4, 3, 2, 1. That is why the code it is like that. But every time the data is generated, in that it will be checking the first 7th bit to 0th bit. Based on that it will be giving the priority. So I hope everyone understands about the priority encoder. We have to write the code and test bench in the EDA playground. I'll be sharing the coding with you. So I hope you understand. If you have any doubts, please ask me in the next class. Thank you.